So I just wanted to start off by saying good afternoon. My name is Allie Taylor. I'm the Tribal Historic Preservation Officer for the Jamestown S'Klallam Tribe. I wanted to welcome you to the Learning Our Landscape series, where we explore the rich history, culture, and environment of the North Olympic Peninsula through monthly presentations from local experts. Today we'll be hearing from Gary Wessen, who has a PhD in anthropology from WSU and has operated as an archaeological consultant in the Northwest since 1983. Gary will be discussing recent discoveries which show that the 12,000-year-old Clovis First idea, which has dominated archaeological thinking for much of the 20th century, is wrong. So just a reminder that we'll be going through questions at the end of the presentation. And this presentation is recorded and it will be available on the Jamestown Library YouTube page in about a week. So let's take it away, Gary.
Okay. Well, thank you very much. And hopefully our technical issues are resolved and we can proceed. And first thing we need is, okay, so you guys can all see that now?
Yes.
Yes? Okay. All right. And like Ellie said, basically, well, I want to talk about what recent findings in the last 10 or 15 years that have really changed our ideas about when people first come to the New World. And let me go to an oversight. Next one here, just an overview. I want to first review a couple of background issues for understanding the issues, and then kind of talk about the history of the research and the Clovis model, and some of the competing ideas, some of the recent findings that have really changed the understanding of most archaeologists, and kind of summarize what we think we know. And because we're talking about Western Washington, I want to conclude with how do these new ideas affect what we know about the prehistory of Western Washington. Um, and when I talk about recent finds, I'm going to go through most of them relatively quickly and spend a bit more time talking about the recent findings in White Sands, New Mexico, where very old human footprints have been found. Perhaps some of you have heard about this in the news. It's really an amazingly unusual and fascinating archaeological site. So I'm going to talk about that a bit more. And let me offer a few caveats or admit to a few biases. This discussion, while we're really talking about the Western Hemisphere, is really going to focus mostly on Western and Northwestern North America. There are a lot of other sites that are relevant to this discussion that are in other parts of the continent that we're mostly not going to talk about. And I should say also, I'm going to talk very, very little about the archaeology of South America. Uh, it's another whole other giant issues. It's obviously related, and I will touch on it briefly in a couple of places. I have to admit that part of the reason I'm not going to talk about it extensively is a lot of the literature is in Spanish, and I don't read Spanish. Uh, but that's the range we're going to go. And then let me add another couple of background thoughts before we get into the real background. I don't know how many of you folks may have had experience talking to archaeologists, but if you have, you may know that archaeologists love to argue with each other. In Western Washington, for a while now, we've liked to say that if you have two archaeologists in the same room, you have about a dozen different arguments going. And a number of the issues around Clovis and the replacement of the Clovis idea are very controversial still, although that controversy is finally beginning to wane. But there was a lot of argument about these ideas in the last 15 or 20 years. And as a last thought, before we just really get into the actual background stuff, let me add, I'm going to kind of waltz through a couple of dozen different issues here in the next hour, and we could spend days or weeks or longer talking about any one of them. So I'm really going to give you kind of a broad brush approach to the issue. Um, okay, let's start talking about some of the background things we need to think about. First off, and I think most people have probably seen charts like this before. This just kind of for the age of the Earth in millions of years, all the way to the present on the left. And just very briefly, the Paleozoic is when we first see life forms with fossils, with trilobites, with hard parts. Mesozoic is dinosaurs. And about 66 million years ago, we have a big asteroid or comet that hits the Earth and wipes out about 80% of everything living on the planet. And then after that, we have the Cenozoic, which is the age of mammals. And then this lower bar shows all the Cenozoic. And the period of time we're talking about here is really right at the end, what's generally referred to as the Quaternary, the last 3 to 4 million years or so. And it involves the Pleistocene. Almost all of that time is the Pleistocene, which is what we normally is the technical term for what we normally think of as the ice ages. And then the Holocene is right here at the very, very end. And the reality is just about everything we're talking about today involves the Pleistocene. And there we go. And okay, here's a time scale on the left we want to look at first. And this is just the last 200,000 years. And this graph is sea level. It's not temperature, but the sea level is closely equated to temperature. And when sea levels are low, it's because if we look over here, during the ice ages, a huge amount
Okay,
of the
about
water. Excuse me? Oh, I'm sorry. I thought I heard somebody say something. Here's a map of North America, and you see when the glacial ice is at its most advanced, a huge amount of water from the ocean's bases is actually locked up and sitting on land in North America and the northern parts of Europe and Asia. And that drops sea level, which exposes continental shelf, which you can see a little bit in this drawing here. And looking back at this chart, the Holocene is just this last little sliver of 10,000 years at the end. And as we look at this stuff, and again, sea levels are equate to how much ice you have sitting on land. The last major glacial events, which on this chart reads as the Wisconsin, which is what they call it in Eastern North America. This part of the world we call it the Fraser, but it's basically the same thing. Has its peak at about 18,000 years ago, at which time sea levels worldwide are about 130 meters, almost 400 feet lower than they are today. And you can see sea levels remain not as low, 60, 80,000 years. And the last time we really have sea levels approaching where they are today, which means very little ice on land and ocean basins are higher, it's about 120,000 years ago. Okay, looking at this map here, I want you to notice that the continental ice sheet that crosses North America is really made out of two separate ice sheets. There's a Cordilleran ice sheet here that is sitting on top of the Rockies, and most of the rest of the continent is covered by a much larger ice sheet called the Laurentide ice sheet that's kind of centered over Hudson Bay. And in this graphic here, it's a little hard to tell, but Alaska is over here. And so to look at this just a little bit better, I want you to look at here, and here again is Alaska. Here's this giant ice sheet. And if we look at this, and this is at about 21,000 years ago, so it's a little bit before that 18,000 year peak, you notice that much of central Alaska and what we call the Bering Land Bridge, the shallow seabed that's actually exposed that connects Alaska to Beringia, Asia to North America, is mostly unglaciated at this time. And it's not that it's any warmer here, it's that this area is basically a polar desert during the Pleistocene. There's not much precipitation. And so much of the last 100,000 years from the graph you saw before, animals and people from Asia could move across to the east, cross the Bering Land Bridge into central Alaska, but they can't get into the rest of North America if they're walking. I want you to also notice before we move on that with sea levels lower, not only is the Bering Land Bridge open around the Kamchatka Peninsula, there's more land here, and the Aleutians are composed of larger islands that extend much further. So there's an island string that runs across here from the Kamchatka Peninsula across into Southeast Asia, into Southeast Alaska. Okay, one other environmental thing that we want to talk about relevant to this period are Pleistocene lakes. And in this graphic, Western United States, and the white up here is the continental margin of the glacier of the Cordilleran ice sheet that extends all the way up into at least parts of eastern Alaska. And you can see there's extended glaciers and the Cascades and the Sierras and some high peaks in the Rockies. But I want you to look at all the lakes that are out here for a moment. In the north, and some of you may be aware about the channel scamblands in eastern Washington when Lake Missoula opens up and floods the Columbia Basin and 15, 18,000 years ago, sometime in that time frame, actually a little bit more recent than that. These are what they call proglacial lakes. They collect the water melting off the glaciers. But if we look into the Great Basin, into Southern California, Arizona, and into Mexico, there are a bunch of other lakes that are not here today that geologists refer to as pluvial lakes. And pluvial lakes are basically basins in the mountains that don't have drainage out of them. And then in a wetter climate, and we think the climate was wetter and cooler when the ice was extended, collected with water, and they created a bunch of lakes through the Southwest that are no longer present now. If you've traveled in the Southwest, you know these things are sometimes referred to as playas, but they're all lake beds, and they were present into, some of them might have been present even into the early Holocene. Okay, having said that, let's look a little bit about how archaeologists date things. And there's basically three different types of dating that we need to be aware of uh, in this for this discussion. And first off, there's stylistic dating. And stylistic dating is when archaeologists find either art or tool types that that they have data that are distinctive and they've dated somewhere. And so when they know when that distinctive style or that technology, the basic age range for it, when they find it in yet other places, they can estimate the date or the approximate date of the age of the thing by noting it's the same style or the same technology as has been dated elsewhere. And that comes into play in these discussions. Then there's relative dating, and relative dating relies to a significant extent on geological ideas, and particularly the geologists talk about something that they call the law of superposition. And all that means is that in the normal order of things, if deposits have not been disturbed by something, the oldest stuff is on the bottom, and as you get more and more accumulation, you get younger and younger and younger stuff as you go to the top. And we can see that in any archaeological site that's not disturbed. You can see that on my desk in terms of paperwork because it's cluttered. Just the whole notion that things that are deeper in the pile are older than things that are higher. And it doesn't necessarily have to go from the top. For example, if there's a layer in a stratigraphic sequence that we know the date of, and we find things above it, we know that they're younger. And if we find things below it, we know that they're older. Okay, absolute dating is using a variety of radiometric techniques that are associated with the decay of radioactive isotopes. And the most well-known and the most relevant for our discussion is radiocarbon dating. And I know there's a lot of text on this graphic that we don't really need to go into, but just very simply, the idea behind radiocarbon dating was invented or discovered in about 1950. But the idea behind it is the cosmic rays from the sun bombard the atmosphere. Cosmic rays hit nitrogen 14 in the atmosphere and split out. And that knocks a proton off, which creates carbon 14, which is an unstable isotope. Carbon 14 is absorbed into living things, principally plants. And then when herbivore animals eat the plants, they absorb carbon 14. And thankfully, when carnivores eat herbivores, they also incorporate carbon 14. And carbon 14 exists in a fixed ratio to regular stable carbon. And when this technique was first invented, people thought that the ratio of carbon 14 to carbon 12 is constant from the sun. And so the decay of radiocarbon could be used to calculate time. Radiocarbon has a half-life of about 5,700 years. And this was wonderful. Archaeologists and other people who wanted to date things got very excited. But as we worked with the technique a little more, a number of problems have cropped up that need to be sort of accommodated and understood when we look at the technique. Now, one of the things that really affects carbon dating is we now know that the rate of solar bombardment from the sun on the Earth's atmosphere is not constant. It changes over time. And so radiocarbon years are not the same as calendar years. And just real quickly, if you look at this table, all of these On this side, radiocarbon years are intervals of 1,500 years, except for the last one, that's only 1,000 years. But if we look at calendar years, and calibrations are now available for this variation, you can see that between 2,000 and 3,500 radiocarbon years is really about 1,800 calendar years. And around the end of the Holocene and into the early Pleistocene, and you're going to see this becomes a very crucial period for a lot of stuff we're talking about. 1,500 radiocarbon years is more than 2,000 calendar years. Archaeologists now have a way to figure out the correction, and you'll hear reference to calibrated radiocarbon dates, or CAL-BP. BP means before present. And all of the dates I'm going to talk about here are calibrated, so they actually reflect real calendar years. But if you've seen publications of older radiocarbon dates, you may often be looking at dates that aren't calibrated, and you need to understand that. Okay, just a few other things about before radiocarbon, and then we can move on to actually looking at the issues for early people in the Americas. Uh, we need to understand that radiocarbon or any kind of radiometric dating is only good for about 7 to 8 half-lives, and radiocarbon's half-life is about 5,700 years. And so that means radiocarbon is good out to about 40,000 years, maybe a little more than that. But if you wanted to date something that was 80,000 or 120,000 years old, you need to go to other techniques that measure the half-lives of longer lived atoms. Okay, two other quick things about radiocarbon that are problematic for the issues we're going to talk about are that, first off, radiocarbon can only be used to date organic materials. And in archaeological sites that are 10,000 years old, or 15 or 20 or 30,000 years old, it's rare that organic materials are still preserved. And so if the only stuff you have in your site are pieces of stone, you can't date them with radiocarbon dating. And another thing to think about real quickly is that radiocarbon dates samples are real easy to contaminate if you're not careful when you collect the material you want to date. In fact, if you handle the organic material that you've collected on an archaeological site with your hands, you're going to get oils from your skin on that sample, and the date's going to come out much younger than we think it should be because it's going to be dating the oil from your hands. And so all of these things are things that need to be understood about radiocarbon dating, but it doesn't mean that radiocarbon dating is not helpful. It actually is very helpful. Okay, let's get on to talking about um, the early folks in the history of just looking at it in North America. This is Bishop Jacob Ussher, just real quickly. Bishop Ussher lived in the 17th century, and in about 1650, um, he decided that he was going to calculate the age of the Earth. And I don't think anybody before Ussher, certainly not in the Western tradition, actually tried to figure out how old the Earth was. Ussher did this by basically constructing a reverse genealogy of the Old Testament of the Bible. And he noted in his work that there are gaps in the Old Testament in terms of who begat who and how long they lived. And so he made what he called reasonable estimations in places where the Bible wasn't clear. And he produced a calculation that suggested that the beginning of Genesis, the first day of Genesis, was actually October 22nd in the year 4004 BC, which is to suggest that the Earth is only about 6,000 years old. Um, we now know that that's, or believe that's way off the reality, but uh, Ussher was the first guy to actually look for evidence to try to understand this. And this notion of a young Earth that he proposed in about 1650 persisted into the late 19th century. Scientists until the 1870s, 1880s mostly thought that the Earth was not very old. It was only about 6,000 years old. Okay, as far as archaeology is concerned, in 1926, near Folsom, New Mexico, archaeologists were doing some digging there, and they found a chipstone spear point here, uh, in direct association with the bones of a prehistoric bison, not modern bison, but an older type of Holocene bison. And that was the first clear evidence, at least in North America, that people had been in North America for a considerable period of time. Again, this is before radiocarbon dates. People didn't really understand when mammoths and mastodons and prehistoric bison and saber-toothed cats actually disappeared, but they knew it was quite a long time ago. And this was the first real evidence that people had that the bones that people were contemporaneous with those animals. Okay, in 1936, another type of similar, very old point associated with mammoth was found at a place called Clovis, New Mexico. We now call the type that was found with the mammoth Clovis points. The first type that was found are referred to as Folsom points. And you'll notice both of these points have a large flake or a couple of flakes taken off the base of the point. And we call these flutes. Folsom points are considered to be derived from Clovis points. Clovis points are a little older. And these types of points, we now know, Clovis is the one I want to focus on. We now know from radiocarbon dating that Clovis points first began in the chronological record in North America at about 13,400 years ago. And they're not being made anymore by about 11,000 years ago. But Clovis points have an incredibly wide spread. Well, actually, before we go to the spread, let me give you a better sense of what these things actually look like, what they're about. These points were put onto a bone foreshaft and mounted sideways so that when you're using the spear, if you break the point, you just replace the foreshaft and your spear point stays intact. And these are some modern replicas of how they probably looked when they were mounted on a shaft. And you can see how this mount here, the fluting the flute scars are where the point is actually hafted on. Okay, here's a map of fluted points from North America at about 13,000 years ago. And the size of these little dots are equivalent to how many are found, and almost 12,000 fluted points are shown on this map. It's an even higher number today because this map is almost 10 years old. But I want you to notice a couple of things here. First off, looking at the continental ice, by 13,000 years ago, both the Cordilleran ice sheet and the Laurentide ice sheet have begun to retreat back. Again, the high point was 18,000 years ago, so this is 5,000 years after the high point. And you'll notice that there's an open corridor between Alaska and the rest of North America. As soon as this corridor opens up, potentially you can move from Alaska down into the United States at any point further south. And talk about this ice-free corridor a bit. We usually call this the ice-free corridor. Okay, looking further at the Clovis points, you can see that there are far more fluted points in eastern North America than there are in the West. And in the West, there's more in the Southwest and into California than there are in the Pacific Northwest. There's only a couple here in Washington, for example. Notice also that we don't see Clovis points once you get into northern Mexico. We don't see them further south. And while we see a bunch in the southern part of the ice-free corridor, and honestly, if we looked at all the radiocarbon dates, these are a little bit more recent than stuff here. And there's none in the northern part of the ice-free corridor, and there's none really in Alaska itself. And so this is kind of inconsistent with what we think about ice, what we think it should have been. Now, I want to show you also, just very quickly, Clovis points from different parts around North America, just because I want to show you how distinctive and similar they are across the board. I don't have scales on all of these, but 5 centimeters is 2 inches. Here's some Clovis points from South Carolina. Here's some from Missouri. You can see they all have this flute at the base. They all have a concave base. And they're relatively large objects. And, you know, these things are at least 3 inches. Some of these are probably a little more than that. Uh, Here's a couple from Nova Scotia. Here's some from Arizona. And I think you can see how similar they really are. And here's a couple from Washington State. There's not too many from Washington. These here, and these are among the largest Clovis points that have ever been found anywhere. These are from Wenatchee. These were in the newspapers about 25 years ago. There was a big Clovis site near Wenatchee. This one is from Kitsap County over near Manchester. It's an isolated find. Somebody found it in their backyard. And this is a drawing. I don't think there are any photographs of one that was found near on Penn Cove near Coopville. And I think you can see the continuity in these things is really impressive. And these Clovis points really represent a cultural tradition. These points are very unique. It's a difficult approach. And we can assume that everybody who made them all over North America were members of the same cultural tradition because the technology is constant throughout. Um, I should tell you, and I should have mentioned in passing when I said there's a lot more in Eastern North America, particularly around Chesapeake Bay. Some people have proposed, I want to mention it, but I'm not really going to talk about it Great Lakes. Some people think that the Clovis points are related to Solutrean points in Western Europe, stuff that's 20,000 years old in what do you call it, in France and Spain, the cave paintings at Lascaux. That idea is not widely supported by archaeologists, but it is in the woodwork, and we should be aware that that's been suggested. Okay, so we got these Clovis points all over North America between about, like I say, about 1300, 13,400 to almost 1150. But the radiocarbon date suggests that these things spread across most of North America very, very quickly, between 13,400 and 12,700 years. So within a period of about 700 years, these things are all over North America. And just as a last point on this, um, these things are called fishtail points from South America. They're extremely widespread all over South America. Their temporal range is overlaps heavily with Clovis, but it starts a little later and it lingers a little longer in South America. And it has been suggested, although not demonstrated, that these things are related to Clovis points, that they're another advancement and development of the Clovis points, just like Folsom points are a development of Clovis points. Um, Archaeologists are still arguing about this, but I think you can see a basic morphological similarity to them. So basically, the Clovis model by the 1950s, 1960s, and again, radiocarbon starts about 1950. And this picture is out of a textbook that was published in the early 1960s. And so here's Beringia, and we see people coming down through the ice-free corridor between the glaciers. They come into the mid-continent, south of the ice, and then they spread across the continent, down through Central America and into South America. And this idea dominated archaeological thinking, like I say, from certainly the 19 or mid to late 1950s until the 1980s, 1990s. Uh, while that was happening, uh, a number of other places showed up around the continent where people claim that there was much, much older archaeological evidence. Most of these places are not really widely accepted today, and there's two basic issues that are problems for them. First off, some of them can clearly contain broken rocks, but not everybody agrees that those rocks were broken by people. And there are other mechanisms that break rocks in the landscape, and particularly landslides or flash floods or high energy mass wasting events will break rocks. And there's a lot of criteria that archaeologists use to kind of decide which rocks are culturally broken and which ones are naturally broken. And then additionally, there are multiple places where everybody agrees that those are really artifacts, but they don't agree how old they are, and there's controversies about the ages. And I want to show you a couple of those to just give you some examples of what we're talking about. Okay, Calico Hills is a place east of Barstow in Southern California. It was first identified. People first started working there in the early 1960s. And in fact, Louis Leakey of Olduvai Gorge fame, the guy and his wife were working in East Africa with 2.5 million-year Australopithecines, got involved in this place. And the Calico Hills is up in here. It's on this ridge up in the hills. And this whole area is subject to, it's desert, but it is subject to periodic flash floods. Uh, which cause landslides and floods come roaring down the hillsides, and rocks get banged together. And in fact, this graphic I'm showing here is from some analysis that kind of debunked it, and he referred to the area as geofact alley. Geofacts are things that geology makes fractured and transport. This is a picture of the area where the excavations actually occurred in Calico Hills, and I think you can see there's a lot of rocks and rubble in the material, and a lot of this has been interpreted as flash flood deposit. So that's where they were getting this stuff. And here's good examples of typical Calico Hills artifacts by the proponents who said that they thought these were cultural. And these rocks are definitely broken, but almost nothing from Calico Hills um, actually looks like a farm tool that North American archaeologists can relate to. They just look like broken rocks. Here's one example that the proponents of the place pointed out. And they said they think that this is a hand axe. And Leakey kind of related them to hand axes that are more than 1 million years old in East Africa. Now, if you really think that the Calico Hills site has hand axes that are more than 1 million years old, then we're not even talking about modern human beings anymore. We're talking about Homo erectus or some earlier hominid that almost nobody believes was actually in the New World. Uh, and like I say, at this point in time, there's still a few people who point to Calico Hills and they say, oh, no, we don't think it's 1.2 million years old. But other people who are still proponents of it say, well, it's got to be at least 400,000 or 500,000 years old. And frankly, nobody really believes that either, I think, or the mainstream archaeologists don't believe it. Okay, another place worth talking about is an archaeological site called Huatulco, and it's near Valsequillo in Mexico. And if you know your geography of Mexico a little bit, it's near Puebla. So it's in the highlands. This is the reservoir. And this place had been known about for decades, and there's much, much more recent stuff there. But some archaeologists working there in the late 1960s found fossilized or mineralized mammoth and mastodon bone, other Pleistocene animals, and they found these objects. And this is just some examples. And these are pretty clearly not geofacts. These are pretty clearly points that were made by people. Um, there's been a lot of controversy around this place because some of the radiocarbon dates associated with the Pleistocene animal bones suggest that this site is 20 to 30,000 years old. However, geologic dating of the deposits using much, much older isotope radiometric studies have suggested that the deposits that these bones and stone tools are in could be 250,000 years old. And we wouldn't expect the bones to be there at 250,000 years. And at 250,000 years, this technology is even advanced over what's going on in the old world at 250,000 years ago. So there's some real problems here with whether these things are actually associated with 20 to 30,000-year-old dates or whether they're 250,000 years old. And there's been a lot of argument and yelling and screaming in the 1960s and 70s, with some archaeologists accusing other archaeologists of fraud and planting things in the site. And so this place remains very controversial to this day. Most people don't think it, well, it could be 20 to 30, but it's definitely not 250,000. Oh yeah, and so that's been going on, and so by the 1980s, a number of problems have been developing with understanding the Clovis First model. And first off, archaeologists who thought, well, if that's the first technology into North America, then we should see it in Northeast Asia also, or at least the antecedents of it in Northeast Asia. And archaeologists have looked for it in Northeast Asia, and they don't find any evidence of anything like Clovis at the late Pleistocene in Northeast Asia. And again, I had here just maybe from Western Europe, and this is this idea that Clovis points actually come from Spain and France, which has been floated, but most people don't take it seriously. Another problem for the Clovis First model is geologists and paleo-environmental people have been doing more study of what the ice-free corridor would have been like. And they say, well, as soon as the ice opened up enough to have a corridor through there, it would have been a glacial wasteland. It would look like, right out in front of one of the glaciers on Mount Rainier. No plants, no soil, no animals, nothing. A completely bare landscape where neither animals nor humans could really survive while they made the trip from Alaska down to the southern part of Canada. It would have taken a while for the ice-free corridor to become a place where animals and people could actually survive. And that might have taken hundreds or even thousands of years, depending on which environmental model you like. Other problems for the Clovis First model included that we began to find evidence of other cultural, technological traditions that are as old as Clovis. And more recently, we began to find evidence of other technological traditions that are clearly older than Clovis. So let's start to look at some of those. By the 1980s, archaeologists working mostly in eastern Washington rather than western Washington, Idaho, Oregon, and down into California, and along the Pacific coast and into the Great Basin, but not further than that, began to find distinctive projectile points that were very different from Clovis points. And here are examples of some of them. They're a long point with shoulders and a stem that sometimes is rounded, sometimes is somewhat squarer. And these things are called Western stem points. And their presence represents a different technological tradition than the Clovis points. These things are clearly different, represent a different manufacturing approach. Some of them were found with the bones of prehistoric animals, prehistoric bison, and things like that. And initial radiocarbon dating of Western stem points in various places in Western North America initially suggested that these things dated from about 13,000 years ago to about 11,000 years ago. And so that's pretty close to the overlap of Clovis, suggesting that at least in this area, Clovis and Western stem point people may have both been present, may have interacted with each other. We don't really know that, but clearly we've got two different technological traditions happening at the end of the Pleistocene in Western North America. And let me show you a couple of these. And these are two from Western Washington. Actually, these are both from out of private collections and not out of archaeological assemblages. This one is from Mossy Rock on the Cowlitz Valley, and you can see the stem was broken off here. It certainly would have extended more here. This is another one that was found in the lower Willapa Valley near Raymond. This one came out of an agricultural field. I think this one did too. I'm not actually sure. But these are clearly Western stem points. And well, Western stem stuff began to make traction in other places, other things started happening. Okay, this is a place called Paisley Cave. And Paisley Cave is near Paisley, Oregon. It's southeastern Oregon, down near Prineville. No, it's not the Prineville, actually, near Lakeview. And just looking at the landscape, here's a bunch of bedrock, and the Paisley Caves are. You can see there's a bunch of lava tubes in here, but this is an old pluvial lake shoreline. This is the old pluvial lake band here. And so this site, we're in rock shelters or caves right along the edge of this pluvial lake. And people started, and people had known that there was stuff here since the 1930s, actually. And typologically old stuff was assumed to be present there. And the University of Oregon started working here again in the 1990s and found that the site contains large numbers of chipstone materials, including Western stem points, and the radiocarbon dates that initially were taken here suggested that these things were about 11,200 years old, which means they're right at the end of Clovis. Okay, University of Oregon came back here and did more work at this location in the early 2000s. And they found more Western stem point bases, and we can see a couple of them here. And they found this stuff. This stuff here is what archaeologists call coprolites. And if they look like turds to you, that's exactly what they are. They're not fossilized fecal material. They're desiccated. They've been dried out. And archaeologists knew that this stuff was in the back of one of the Paisley caves. And for a while, nobody was interested in it. They assumed it was animals. But for some reason, I never got the story. Somebody decided to radiocarbon date some of these things in about 2010. And I'm not sure which sample it is here. They ran several of them, but the coprolites date to about 14,500 years, significantly older than Clovis. Um, and that provoked some people to extract DNA out of the coprolites. And yes, you can get DNA out of coprolite, and they're human. So we have strong evidence that human beings were occupying caves in southern Oregon 14,500 years ago, significantly older than Clovis, and actually that was older than Western stem points were thought to be at the time that this work was done. Okay, another place. Cooper's Ferry is in Idaho. This is on the lower Salmon River. River's flowing that way. This is yet another place where people knew that stuff were present for decades, but not much work had been done there until relatively recently. People from Oregon State University worked here between 2009 and 2018, and they recovered a lot of stuff here. And here's some examples of the projectile points. These are all perfectly good Western stem points. They all come from the Cooper's Ferry site. And in this graphic, associated with stuff, because this is more of the Cooper's Ferry stuff. I think this stuff is actually from Cooper's Ferry also. But these projectile points down here are not from Cooper's Ferry. In fact, they're not from anywhere in Western North America. They're from Japan and around the Okhotsk Sea, which is the area west of the Kamchatka Peninsula in Asia, just to the north of Japan. And they are occurring around the same time in that part of the world that Western stem points are showing up here, and particularly if we're looking back as much as 16,000 years. This has led a number of people to speculate that this stuff is related to this stuff in Japan and Northeast Asia and the Okhotsk Peninsula. And if you think about it, and I should say also, we know from work in Asia and Japan and the Kamchatka Peninsula that people were maritime at that point in time, that people in Japan and Kamchatka were sea hunters, had boats, knew how to take marine mammals. And if you think about it a little bit, when the Bering Land Bridge separates Asia and North America, so the polar Antarctic waters are not coming into the North Pacific, you have a continuous shoreline from the Kamchatka Peninsula all the way around the San Francisco Bay, if you like. And the marine resources for people to hunt in the North Pacific at that time are pretty much the same. You got salmon, you got other marine fish, you got seabirds, you got marine mammals, including whales. And they're mostly the same animals. So if you have a culture that is in northern Japan and Kamchatka and knows how to make a living off the ocean, it would be relatively easy for them to spread along that coastline. And if you remember the graphic that I showed you of Beringia, the Aleutian Islands have more larger islands at the time when sea level was lower. So people could have followed all the way around from the Northeast Pacific to Northwest Pacific all the way around to the Northeast Pacific. And there's increasing thought that, in fact, that's exactly what happened. Um, okay. Just another site in Oregon in terms of Western stem stuff. This is Rimrock Draw. This is near Ripley, Oregon. It's only about 70 miles actually from Paisley Cave. And if you look here, this rock outcrop there, that's another shoreline, and this is another old playa. So this was on another pluvial lake. And work here began in about 2002. And a lot of initial work was done there. Um, in the early 2000s, and lots of good Western stem points, broken ones. That's a good base. That's a good base. This is a Western stem point. That is, so is that. And the initial radiocarbon dates for here on Western stem points put them to be about 13,300. That's not as old as the Cooper's Ferry stuff I just told you about, but then more work was done here in 2015. And among other things, this stone scraper, which by the way had blood residue of antique bison on it, was found underneath a volcanic ash layer that geologists had demonstrated was about 15,800 years old. So that means it's older than that date. That puts it into the kind of the Cooper's Ferry time range. And then additional work there found some camel teeth, and there were camelids, and Pleistocene faunas. And this is a piece of the enamel from that camel tooth that was radiocarbon dated, because none of this stuff could be directly dated, radiocarbon ways. And the radiocarbon date on this piece of camel tooth is 18,250 years old, which pushes back Western stem even further into time. Okay, another site that is worth talking about here, and this one really put the kibosh on the excuse me on the Clovis point, on the Clovis culture. Although I think you can see already there was increasing reason to believe that Clovis is not first. This site is called the Galt site, Texas. It's really pretty famous now, and actually, if you're interested in this literature at all, you may have seen reference in past years to a place called the Deborah L. Freakin site. I don't know what the personality politics is all about, but this is the same place. It used to be called Deborah L. Freakin. Now it's called Galt. It's in Texas, not far from Austin. And so certainly there could be Clovis points in the area, but this is well outside of the range of Western stem points. And just quickly here, a lot of this site was looted and disturbed because, again, it's another place that's been known about for many decades. But this site really put the nail in the coffin for Clovis because it has a Clovis component. It's right here. And it has another cultural component underneath the Clovis. And again, law of superposition, even without any type of radiometric dating, if these layers are all intact, and they are here, you can see there, it is stratigraphically beneath Clovis. It has to be older. Now, the dates are here, and I have to tell you, these are not radiocarbon dates. These are what are called optically stimulated. God, I forget what the last term is for it, but it's a different radiometric technique. Optically stimulated luminescence. It's a much newer technique. It's more complicated radiometrics than we really need to go on here. Some people don't like it, but it's becoming increasingly more acceptable in recent decades. And most archaeologists accept these numbers. Here are the dates. And you can see at Galt, the Clovis stuff is between 13.2, most of these states, 1312, 11 in this range. And then the Galt stuff ranges between about 16,000 and almost 22,000 years. And this is very, very well controlled, multiple dates. Not, and nobody really disputes that this stuff in this lower level are not artifacts or not cultural. Here's an example of some of the Galt assemblages. And again, these are undeniably older and stratigraphically beneath Clovis at the same location. And there's no question that these are artifacts. We have some big bifaces and points here. And we see some very small projectile points also. These things are small, although some people dispute whether these are projectile points, but that certainly is. And these things don't really have an analog anywhere else in the New World that we know of at the time frame that we're seeing this stuff. So, but this site, more than any other, really put the coffin, the final coffin nail into the Clovis was first issue. And here's something else that the Galt site has that are really interesting. These are pieces of sandstone with etched patterns on them. And somewhere between 17 and 21,000 years ago. Objects like this appear in multiple archaeological sites much more recently. I believe there are even some pieces from Chichen, the site in Port Angeles, that are at least superficially similar in terms of the etched patterns on them. Um, we don't really know what these things represent, but at the moment, they are strong candidates for being among the oldest uh, art objects from any place in North America. Okay, the last site I want to talk about here is the White Sands site, and hopefully some of you have seen some of this stuff. It's been in the news a bunch in the last couple of years because it's unlike any other paleo site in North America in that there are no artifacts here. What there are footprints, amazingly preserved, that tell amazing stories. And so I want to talk about this in just a little bit more detail. Okay, this is White Sands, New Mexico. It's in southwestern New Mexico. And just a map of it here. I've never actually been here. I don't know whether any of you folks are. But this light blue stuff, Alkali Flat, Paleo Lake, Otero, this is a big pluvial lake. And these gypsum dunes, which is what the White Sands are all about, have a much larger deposit here. And they have been blowing in across the old lake bed. They start off the lake bed, although possibly the lake bed went further, but they're encroaching onto the lake bed. And the area that we're talking about is up in here on the lake bed. And just to give you a quick sense of what what the place looks like, these are the gypsum dunes, the White Sands, and Lake Otero is further beyond them. And this view, we're looking kind of to the west. And this is what the lake bed itself looks like now. And you can see Barkan dunes encroaching onto it, but there are also extensive surfaces here where the old lake bed is still exposed. And I had to throw this in. The National Park Service has done a lot of artwork associated with the finds here. And this is a picture that they like to show what they interpret the city when these things were. And I don't think the mammoths were ever as close as kids playing in the mud, but you could see mammoth footprints here, human footprints here. And the interpretation of the area is that it wasn't a big lake that filled the whole area, but there were lots of small watering ponds and places like that. And what you see here in the front are a bunch of kids playing in the mud. Um, I'm not going to show you any track footprints that actually show this, but because I haven't been able to find them. But the people who do that say, yeah, there's places here where we see preserved footprints that are not adults, they're children, and we can tell a little bit by the sediment as to what they're into. And it looks like we have preserved examples of kids playing in the mud or playing in shallow water. Um, Okay, so what the evidence actually looks like here? And on the top here, you can see that there are 7 different types of animal prints that are known to be present out on this old playa. There are bear tracks, canids, probably direwolves or something like that. This is probably before dogs are present in North America. Felids are saber-toothed cats. Xenotheria is a term most people are probably not real familiar with. Xenotheria refers to a class of placental mammals that include things like anteaters, armadillos, and sloths. And in this particular case, what we're talking about are ground sloths. In the Pleistocene in North America, there were giant ground sloths. And I'll show you a picture of one in a couple of moments, but the large animal. We see lots of evidence of ground sloth here. We see camel tracks. Proboscideans are elephants, mammoths, and mastodons, and human footprints. And they find 6 different types of these prints. Um, and just real quickly, I want to go through all of the types in detail, but the different types include both casts, where have an impression in, and other places where the footprint has compressed the material, like here in 5. And then it's harder and it's more resistant to erosion. So some of these things are positives and some of them are negatives. And you could see examples of each one in these set here. And you'll see another example as well. There's quite a range in how sharp some footprints are, and others are much different and more sloppy. And they think that it depends on the range of sediments. Some of them are in clay, some of them are in fine sand, some of them are in coarse sand. And the moisture differences were considerable as well. So some people were really slopping through mud, other people were walking on surfaces that were drier and firmer. A real range of things represented here. And let me say also, these things are now being exposed by the wind, which is deflating the sands on the old lake basin that exposes these things. They were probably not exposed until relatively recently, although other ones, younger ones, may have been exposed as the ground went down. They're absolutely amazing, but among other things, they don't preserve real well. And the ones that are exposed on the surface now are subject to being blasted by the winds as well. And well, awareness of this thing has only happened within the last 5 years, so they don't really know. The people studying these things think that they probably don't last for more than a couple of decades, and the wind blows them away completely, and then they're gone. There may be more that gets exposed, and actually the Park Service is looking at ways to try to preserve some of them so people can see them at some time. But they are relatively fragile once they've been exposed. Okay, real quickly, and a lot of this stuff here is actually from, there are some people who specialize in footprint analysis, really pretty amazing. They're having a field day here. And they tell us that, first off, these footprints can tell us people are present. We get some idea of activities, other animals in the area and how they're associated with each other, ecological reactions between humans and people, walking speeds and biomechanics, roughly how many people are in the area, stature and height of people, and age profiles. So people who study footprints are actually being able to tell an amazing amount of things about these locations. Okay, let's look at a couple of them. Here's a one track, and some of these tracks are very long. Some of them are more than a quarter of a mile or more than that even. I understand some are almost a kilometer in length. Here we see single individual who walked to the north and someone of similar stature walking back. It may have been the same person, may not. And between the time that the person walked north, a mammoth or a mastodon walked through the area. These are his footprints here, here, here. And you could see the person walking back stepped in the fresh footprint and continued on their way. Whether these people saw that, whether the elephant and the people saw each other is not clear, but the people who study these things think that these things could have happened within an hour or two of each other, very close in time. Another example, and if you've seen any of these, you may well have seen this one. This is one of the more famous ones. Some people call this Eve's track. And on the top, we see, I think this was taken from a drone, what the surface looked like when archaeologists first found it. You can see footprints here, footprints there. There's a couple of things here that are already exposed. I suspect these were done by the archaeologists before they took the picture of the whole track. Here's what it looks like when they cleared it and actually exposed all of the footprints. You could see a single individual walking this way, individual walking that way. And in fact, here, when it's mapped, it's clearest. And this is just a segment of it. It goes much further in both directions. But if we look here, we have somebody walking along. And then here, we see a small child's 2 feet here. It's another foot there. And the interpretation of the people who specialize these things say this is a person, probably a woman, who was carrying a small child. And when she got to this point, she put the child down for a minute. Child didn't really walk away, but the child was put down for a bit. They suggest that she probably shifted her load or was carrying other stuff than that, or that she may have been carrying the child on one hip and she wanted to change it to the other hip. But she stops for a minute. She puts a small child down, and then she picks the child back up and she continues on her way. And there's a second track that they think is nearly contemporaneous with it. And this is either the same woman or somebody of nearly identical stature and size as this person. At least ultimately, there's no way to tell whether this person and that person were actually the same, but they suspect it might have been. If it is, she's now going back to wherever she came from. And they say if you look at the spacing between the footsteps here and what's happening here, she's just kind of walking here. She's hurrying here. She's moving more quickly and in this other direction. Now, we don't really know where she was going, where she's hurrying back to, what happens to the small child. But this is a small bit of human activity in the deep past that we see with a kind of intimacy that we just about never see in archaeological sites. It's really quite amazing. Um, okay, I mentioned ground sloths before, and most people are probably not familiar with Pleistocene giant ground sloths, but this is a reconstruction of what this critter probably looked like, and this is a 6 foot tall person. And you can see this is a very large animal. I mean, it's not as big as a mastodon or a mammoth, but it's a large animal. Okay, here's a set of tracks that they've done a bunch of work with, and actually there's some difference of opinion on interpretation of this one as well. And you can see there's somebody walking this way, human, and somebody walking back, and they think the time interval is similar. I don't know whether they think it's the same person or not, but there is a ground sloth, set of ground sloth tracks here, and the ground sloth came in from this direction, and somewhere around in here, the ground sloth got up on his hind legs because this is the mark from his tail. And he kind of stands up and looks around, moves around in a circle, and then moves off this way. Some people think that this ground sloth was actually attacked by the humans, and that's why he rose up. Other people go, no, they don't think he was attacked, but they think the humans were probably close enough that he got up on his hind legs to see where they were. And either whether he was attacked or whether he just saw him and he didn't like it, he was moving in this direction before he gets up and looks around. And then he gets up and looks around, makes a circular movement, and then moves off in a different direction. So whether he was actually attacked or not, most people think that he was close enough to the humans to see him, and he altered his line of movement away from them. Again, something else that we almost never see in archaeological sites. Okay, so how old are these things actually, and how do you date them? Here's an example, a close-up. I hope you can see that. Here's one of the human footprints, and there's all these little black dots in there. There's a couple little piles of them here, but you can see a lot of black dots. These are Rupia chirosa seats, spiral ditch grass. And spiral ditch grass is still common in the Southwest today. It's not really a desert plant. It grows in moist areas or where there is some kind of water source. And it's still common in the area today. These are what these tiny seeds look like. A lot of very careful work was done. They didn't date them right here, but a lot of stratigraphic work was done to find the individual layers. And there are many tiny multiple layers that these footprints are on. And then they followed that surface away from the footprints, collected seeds that were not disturbed by walking, and radiocarbon dated the seeds. And you can see actually from this graphic, and again, everything up here is blown away. We're missing a whole bunch of stuff from deflation by the winds, but there are footprints and animal prints over a considerable part of this column. And frankly, the archaeologists spent just about all their time trying to date the bottom because these are the oldest ones. These are going to be somewhat younger. We know that Pleistocene animals like elephants are gone by about 10,000 years ago. But the lower part of this stuff have dates that are in the 21 to 22, almost 23,000 year range. And we're not looking at a situation where we have to argue about whether these stone tools were actually made by humans or not being humans. These are footprints. There's no question that the humans involved. So this is probably the strongest, most indisputable evidence that these things are human at 22,000 years. Okay, so just a couple of quick wrap-ups here. So what can we say? We know now. And first off, we can say that people were certainly in North America by 23,000 years ago. And so there's just no question that Clovis was not first. Clovis is still a very interesting phenomenon. It's a continent-wide phenomenon, but these are clearly not the first people in North America. People were certainly present by around 23,000 years ago. Further, I think we can say that the people who left the footprints in White Sands were not the first people in North America. And frankly, depending on where you think they came from, if you think that these are Western stem people traveling down the coast, the Pacific coast, and then it's worth noting that this location is about 600 miles from the Pacific Ocean in San Diego. It's about 400 miles to the top end of Baja California, the Gulf of Baja California, the Sea of Cortez, if you will. But because of lowered sea levels, there probably wasn't seawater there. So we're talking about at least 600 miles from the nearest marine coast on the Pacific, if you think that's where they came from. If you think they actually came to cross a land bridge, you got a couple of problems here. First off, it's more than 3,000 miles to central Alaska, and that would have taken a while. On top of which, at 23,000 years ago, there is no land bridge. So if you think they walked to North America, then they have to be considerably older than 23,000 years ago. And in fact, we might be talking about 80 or 90,000 years ago before there's an earlier land bridge. So we don't really know how old and when the first people were, but clearly, these people that we see evidence of at White Sands are not the first people in North America. How much older might they be? And, we're still arguing. In fact, I didn't really add it into this show because I'm running along already. But there's a site in San Diego County, near San Diego, right now that's called the Coretti Mammoth Site. Some of you might have heard of it. It's been in the news a bunch in the last 5 years or so. And the Coretti Mammoth Site is definitely well dated to 130,000 years old, and it's a mammoth skeleton. And mammoth skeletons don't need to be archaeological sites because elephants die all by themselves. And there's a lot of mastodon mammoth sites in North America that are not cultural. This particular one has some broken bones and some rocks near it that some people think is cultural, that humans broke up this carcass and butchered it. Whether they killed it or not, who knows. Um, the jury's still out on that. A lot of people don't think it's cultural. There are some people who think it's an interesting idea and is at least worth serious further study. Uh, but we don't know how much elder. But there's another thought that we should think about a little bit in this context. Um, if there really are evidence that human beings were in North America at 130,000 years or some early time depth, it's not necessarily the case that people have been here for 130,000 years. Well, that's certainly one possible interpretation. It's also, while we're just thinking about possibilities, it's a possibility that the first human colonization of North America was by a relatively small group of people, and it failed. And so they were here for a little while at 130,000 years ago, but they didn't successfully survive. And then a later movement of people came in that was more successful. And there's no particular evidence for that. I'm just saying that we need to be open to what all the possibilities are. And one of the possibilities is there's much more ancient stuff here, but it doesn't represent the beginning of constant occupation of North America. It represents an early movement and that did not succeed. We don't know. Okay. Another thing we could say with some confidence is that people may have gotten here by more than one route, although obviously one of those routes was first. And it's looking increasingly that the first people who got here by boat. And And because we're seeing movement at times when the land bridge is simply not available. People crossed over here in the last 25 to 30,000 years ago. There's no land bridge. You can get to Alaska, but you can't get out of Alaska because the ice-free corridor isn't there yet. And finally, as a last thought, it's safe to assume that this research trying to determine how long people have been here will go on for a lot longer. It's not close to being solved now. And part of the reason I say that is the very first people who came to North America, whether it's the Carretti Mammoth site or wherever it is, it's very unlikely that they left any physical evidence that indicates that they were the first ones. It's even possible that we already know what the oldest one is. It's not well established yet, but people are going to keep looking for older ones, and it's going to take getting the research to a point where for decades we don't find anything older than a certain date. And that's what's it's going to take for people to begin to think that maybe that's really what happened. Okay, just very quickly to wrap up, I showed you this map from 1960s. Now we're probably talking about uh, possible moving through the land bridge, western stem points coming down and then evolving up to something there, possible Solutrean movements in. And some people think that some of the sites in southern uh, South America, and there are some there that date to about 14,000 also, might represent movement out of Australia and early pre-Polynesian peoples moving across that way. So there's a lot to think about here. And then finally, as my last point, I just wanted to talk about, well, what does this mean for us here in Western Washington? And first off, you probably know about the Manus Mastodon site, or at least I've heard that there's a site just outside of Sequim where cultural material associated with a mastodon skeleton were exposed in the 1980s. Um, we now have radiocarbon dates. We had some earlier, but the radiocarbon dates from the last 10 or 15 years, more recent, make it pretty clear that that Manus mastodon dates to about 13,900 years ago. So it's a little too old to be Clovis. There are no projectile points there. There are no stone tools there. So we don't really know who is there. But we can now say that it's very unlikely to have been Clovis people. We don't have any indication that Clovis people were actually running around 13,900 years ago. So the only other candidate that we have at the moment is Western Stem Point people, as being the people responsible for the Manus Mastodon site. And the recognition that Western Stem Points are earlier than Clovis um, has some interesting implications for when you think the beginnings of maritime adaptations in the Northwest coast or in Western Washington occur. Under the Clovis model, if you recall, the first people would have come into the mid-continent down the ice-free corridor and then spread to the east, west, and south. And under that model, the first people to occupy Western Washington came from the east. They came from the interior, and they were not maritime people. And under that model, we visualized people coming into Western Washington and beginning to learn about saltwater and slowly adapting first to Puget Sound and only later becoming adapted to the outer ocean and the more severe maritime regimes that the outer coast offers. If we dismiss the Clovis model and we say Western Stem Point people were first, were here before Clovis people were, then we're talking about people who were maritime the day they got here, who traveled along the coast of the North Pacific out of East Asia, from maritime traditions that could be 20 or 30,000 years old. So shifting to the Western Stem Point model, we can have much, much earlier occupations. In fact, we would argue that there were probably maritime people here from 13,000 years ago. And finally, a last idea that has been thrown around by some archaeologists in Washington, which I think is worth thinking about, although we don't have a lot of strong data for it. But if you think that these Western Stem people are moving along the coast and occupying, islands offshore or narrow coastal margins that are very weird, and you wonder, well, we see Western Point people into the interior. I've showed you places in Idaho where they exist. Where would they have entered the continent, leaving the shoreline and actually go into the interior. And we know for much of the late Pleistocene, the continental ice overrode the Strait of Juan de Fuca. There's arguments about how far along the coast it extended southward, and probably didn't go too far. Probably may not have gone down as far as the push, but we know that the glaciers in the Olympic Mountains heavily expanded also, and they went overrode the coast. And people have suggested that if you were coming down the coast as some of these maritime folks and you wanted to go into the interior, where was the first place you would come to as you come south beyond the edge of the ice, where you have a good route into the interior? And people looking at that question have said, well, Gray's Harbor and the Chehalis River would have been the first major river corridor that was ice free 13,000, 14,000, 15,000 years ago, where these people could have actually left the coast and journeyed into the interior. We don't have a whole lot of evidence for that as yet, but it's a real interesting idea. And I think I'll leave it there. And as a matter of fact, I think at this point,